Hello and welcome back to Edu-Malanga. Today we are doing the last video on the sum of geometric series. In this video we're going to do two examples on sum to infinity of certain kinds of geometric series. The sum to geometric series is the fourth lesson in the first unit of the year, which is patterns, sequences, and series. Let's get started doing examples on the sum to infinity. The first example we will look at, example 1, asks us to calculate the sum to infinity of this series, and the series is Sn 12 plus 3 plus 3 over 4, and so on. So the first thing we're going to do is remind ourselves of the formula for summing certain kinds of series to infinity. And the kind of series that you can sum to infinity is a series that converges. So let's start by writing down the formula. The formula looks like this. Sum to infinity is equal to a, which is the first term, divided by 1 minus r, which is your common ratio. And in order for you to be able to sum a series to infinity, it's important to note that negative 1 must be less than the common ratio, which must also be less than 1. So you'll only be able to sum a series to infinity when your r falls in between these values. Let's check now for the series that we've been given then. So we need to find a according to the formula. A we can simply read off there. A is equal to 12. And what is r? R we must calculate ourselves, and that's equal to term n divided by term n minus 1. Which is basically the term that you're looking at divided by the previous term. So let's go, for example, if we choose to look at term number 2. So we're going to then have term 2 divided by term 1, which is the previous one. And that will be 3 divided by 12, which is equal to, when simplified, you can divide 3, okay, becomes 1. And 12 divided by 3, that's equal to 4. So our r is equal to 1 over 4, and that does fall in between negative 1 and 1. So with this series, we know that we can sum to infinity. Let's start summing to infinity now then. S to infinity is going to equal to, our a is equal to 12, if we remember, 12. Divided by 1 minus r, which we solved for as 1 over 4. Okay, we'll simplify what's happening in the denominator. We're going to have 12, 1 minus a quarter, that leaves you with 3 quarters. So that leaves you with 3 over 4. Okay, and if we rewrite this expression, we're going to have 12 divided by 3 over 4. That'll equal to, remember when we're dividing expressions like this, we swap the numerator and the denominator, and then we change the sign to multiplication. So we will have 12 times 4 over 3. Okay, again the 3 can cancel out, so the 3 can become 1, and we can divide the 12 by 3 as well. 12 divided by 3, that'll equal to 4. So in the end we have 4 times 4, which is 4 squared, and that's equal to 16. So the sum to infinity of this series, 12 plus 3 plus 3 over 4 and so on, is equal to the number 16. That was easy enough to solve, right? Okay, let's move on and look at example 2. In example 2, we're asked to calculate the sum to infinity of this series. Sn is 4a plus 2a squared plus a to the power 3, and so on. Okay, we now have a variable a in our series, but nothing changes. The rules stay exactly the same. So let's do it again. We're going to start by rewriting the formula. S to infinity is equal to a divided by 1 minus r. Let's define again our variables. A is equal to 4a. A is equal to 4a. Okay. And what is our r? R is, again, we're going to just use term 2 and term 1. Our term 2 is 2a squared and our term 1 is 4a. So our r is then going to equal to 2a squared divided by 4a. Let's see what happens. 2 can simplify to 1 and 4 can simplify to 2. Okay, so then we have 1 over 2. And what happens on this side? A squared divided by a. This a will cancel out. And on this side we're going to be left with 1a. So then we get 1 over 2a, which can be written as a over 2. And that is our r. Now that we have a and r, let's substitute into the equation and solve for the sum to infinity. Our sum to infinity then becomes equal to, open our brackets, we have 4a divided by 1 minus a over 2. We can't simplify this expression any further because we have 1 minus a over 2. So this is about as far as we can go to solving for the sum to infinity. But the question continues and asks us, for which values of a will the series not converge? In order to answer this question, let's remember under which conditions does a series converge. A series will converge when you have negative 1 being less than your r, which is less than 1. So this question looks at r alone. Okay, let's come back then and just come back to what was our r. Our r is equal to a over 2. So in this question, r is equal to a over 2. So let's substitute in a over 2 where we are seeing r. We will then have negative 1 should be less than a over 2, which should be less than 1. We have a division by 2. If we multiply everything by 2, times 2, times 2, and times 2, this 2, the divided one, will cancel out, and then the equation will become negative 2 should be less than a, which should be less than 2. And under these conditions, the series is going to converge. But the question has asked us, for which values of a will the series not converge? So we know that it converges when your a is between negative 2 and 2. What happens is, for it to not converge then, we're going to have a be less than negative 2. So we've swapped it around. When a is less than negative 2, for example, a is equal to negative 3, going on and on, the series is not going to converge. And when you have a bigger than positive 2, so when your a is equal to 3 and going on and on, these are the conditions under which your series is not going to converge. The last question we will answer about this series is that if a is equal to negative 1, calculate the sum to infinity of the series. We'll come back to this sum to infinity where we solved it. We stopped right here because we couldn't simplify any further. So let's rewrite this equation over here. We know that the sum to infinity is going to equal to 4a divided by 1 minus a over 2. So the question says if a is equal to negative 1, we should calculate the sum to infinity. Everywhere we see a, we're going to substitute in negative 1. The sum to infinity will then be equal to, sum to infinity will equal to 4 times negative 1, close our brackets, 1 minus, open brackets, negative 1 over 2. 4 times negative 1, that's just negative 4. Denominator, we have 1 minus negative 1 over 2. When you have 1 minus a negative number, guys, what happens is it becomes actually an addition. Check it out with your calculator if you don't believe me. What you will have is then you get 1 plus 1 over 2, because that negative, the two negative signs become a positive. Then we have negative 4 divided by 1 plus 1 over 2. If you make this a fraction that is 2 over 2, you're going to have 2 plus 1, so you get 3 over 2. We're going to rewrite this again. We're going to have negative 4 divided by 3 over 2. And we're going to swap the numerator and the denominator and change it into a multiplication sign. Still, sum to infinity is equal to, yes, that's going to equal to negative 4 times 2 over 3. So then we're going to have negative 4 times 2. That's equal to negative 8 over 3. So the sum to infinity when a is equal to negative 1 is negative 8 over 3 for this series. Thank you very much for joining us to do these examples today. I hope you were writing everything down as I was doing it, and that you were pausing and stopping and using your calculator. Join us again in the next video. We will be looking at a new lesson, which is sigma notation.